We got a certain type of problem that we see in math. They're generally called mixture problems. Not gonna lie to you. Usually, most years, this is the type of problem that kids have the hardest time with out of the systems of equations problems. There's a little bit extra to them. So you got two possible ways usually these mixtures can work. They're going to be mixtures of two percentages, or they're going to be mixtures of two different dollar amounts. Either way, your first equation is going to be the amount of one of them plus the amount of the other equals your total amount. So that's going to look something like, x plus y equals some number. All right. The second equation still is going to look the same on either of these types. It just, whether it's money or a percentage. If it's a percentage, you want to use the decimal value for the percentage. So if it was 25%, you would do 0.25x. And then if it was, 80%, 0.80y equals, and they're going to tell you that you're looking for a total percent with the total amount. So the total percent that they could be looking for might be 65%, and you have to multiply that by whatever this total number was to begin with. All right, see how it's got like that little bit extra to it? So here's how this works. And basically, ones, you almost have to use calculators for. They can't really do this on the inactive, okay? So we got a scientist is mixing a 10% saline solution with a 30% saline solution. How much of each type should be used if they want 6 liters of an 18% saline solution? All right, so how much do they need? 6. They need 6 liters. So I'm going to do x and y. So we got x plus equals 6. There's my first equation. Easy enough, right? You find whatever the total amount is, and the two things add up to that. Now we take the two different percentages. One of them's got to be x, one of them's got to be y. Doesn't really matter which one's which, but you just have to keep straight which one's which because, it might just ask for one of them. So 10%, I'm going to make that x, 30%, make that the y. On the other side of the second equation, I'm going to have the 18%, or whatever the percent would be, times my total amount. Okay? Everybody okay with each other? Not horrible setting them up. Like I said, just a little bit more to it, especially on the right side on that second one. All right, so now we're going to rearrange some stuff. The easiest way to solve these is to set the first equation so it's whatever the tinier coefficient is equal to the rest of it. All right? So you see I've got x as my tinier equation, right? Or tinier solution. So I want this to be x equals up here. I want to substitute the x. So to rearrange that, all I'd have to do is subtract y from each side, right? So if I subtract y, I have x equals 6 minus y. And it's important you have the right order on those, okay? Everybody good there? All right, so now we're just doing substitution. Could you do elimination on this from the start? Yeah, but then you're multiplying everything with decimals, and sometimes that gets a little messy. So if I put in for x, I got 0.10, and then in some parentheses, I got 6 minus y, not equals. I don't know why I put an equal sign. 0.10, we got 6 minus y 0.30y equals, I can go ahead, I can do the multiplication there, 0.18 times 6 is 1.08. And we're going to get a lot of decimals with these, okay? So now I distribute. My 0.10 times 6 is going to give me 0.6 minus 0.10y plus 0.3y equals 1.08. And the reason it's going to be helpful to make this here, to make that one so it's the smaller coefficients equal to, when I combine these now, I'm going to have a positive coefficient still. So when I go and combine these, I still got the 0.6, the minus 0.10, and the plus 0.30 makes that a plus 0.20 y, and it equals the 1.08. All right, everybody good there? Now, we're running out of space a little bit, so we'll see if I can shrink that down. All right, so I'm going to take that equation I have here in green, and that's what I have to solve. So to solve that, I subtract the 0.6 from each side. So I got 0.20y equals, and then my 1.08 minus 0.6 gives me 0.48. And then I divide by the 0.20. So my y equals 2.4. Use that right there. 6 minus 2.4 means my x value is going to be 3.6. Okay? Any questions on that? A little bit more to it, right? All right, I'll do another one. All right, so this time we got a mixture of gummy bears and gummy worms. It's a 2-pound mixture. It's going to sell for $3.19 per pound. The bears cost $2.95 per pound, and the worms cost $3.55 per pound. We need to know how many pounds each. So, you know, this one, instead of X and Y, I'm going to use B and W, bears and worms. The other one, since they were all saline solutions, there's not really a obvious variable I could use. So we got our bears plus our worms. The bears plus worms have 2 pounds. So you can already tell we're going to have small numbers. We're probably going to have decimals here, right? The bears are $2.95 per pound. The worms are $3.55 per pound. The total, the 2 pounds, is $3.19 per pound. All right, so since bears are smaller or lower price, I'm going to subtract W from each side. So my B will equal 2 minus W. So I'll substitute 295 times 2 minus W plus 355W equals, what's that got to be, 638. 2 times 319. All right, so we distribute. Everybody good with that? We just distributed there. Now we combine our like terms. So I got my 590 still. Minus 295 and a plus 355. That's going to give me a plus 60 cents with the worms. And it's going to equal $6.38. So we'll move it up and over here. I subtract 590. So 638 minus 590, I'll have 0.60 with the worms. And when I subtract those, that gives me 0.48. Now we divide. 0.48 divided by 0.60. Worms, I got 0.8 pounds. We just used that equation right there. 2 minus 0.8 means for the bears, pounds of the bears. Okay? One of the things you can tell a lot of times with looking at these there's the price of the bears. There's the price of the worms. Here is the total price. $3.19 is closer to $2.95 than it is to $3.55. If it's whichever one it's closer to, there's got to be more of that amount. So this one was closer to the more bears. If I go back to the other one, we had a 10% and a 30%. 18% is closer to 10 than it is to 30. We had more of the 10% solution. Okay? All right, y'all try this one. We'll make some juice this time. A lot of similar mistakes with your equations. All right, so we got apple juice, grape juice. I'll use A and G. So first equation, the apple juice plus the grape juice, we're making 10 gallons. Second equation, apple juice is going to be 60%. The grape juice is going to be 10%. And what that equals is the 0.45 times the total amount, the 10 gallons. A lot of y'all were leaving off that. All right, so now go ahead from there. What you got? All right, so when we go to solve this, I want the one with the smaller coefficient to be what we're solving the first equation for. So G has the smaller coefficient, so I want to subtract A from each side. The reason I do that is if I make the larger one what it's equal to, you're going to end up with negative numbers. You'll have negative coefficients. When you do the subtraction, you'll have a negative number over there. It's just going to make it more you got to keep up with because you got negatives. So now we're going to substitute for G. So I got 0.60A plus 0.10 times 10 minus A equals, when I multiply that out, that is 4.5. I distribute 0.60A plus 0.1 minus, or sorry, not 0.1. 0.60A plus 1 minus 0.1A equals the 4.5. Combine like terms, 0.60 minus 0.10 is 0.50A. I'm going to go ahead and just subtract the 1 also. So that gives me 3.5. When I divide then, A is going to equal 7. So A equals 7. Our first equation here, we got G equals 10 minus A. So 10 minus 7 G is equal to 3. Any questions there?